everyone, so today we're doing a review of Algebra 1 and geometry and talking about radicals, and we're going to learn how to simplify them. So in this video, radicals are simplified, meaning made simpler. And we all know that I love math, but this right here is a radical, okay? And the value under it is called the radicand. In this case, our radicand is a heart. And it's the inverse operation of a square, okay, of a perfect square. All right, so perfect squares are numbers that are made by squaring a whole number. The square root of a perfect square is a whole number. So when I take the square root of a perfect square, it is a whole number, also called a rational number. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. These are all perfect squares. And if I took the square root of them, they give us the numbers either 1, 2, 3, 4, 5, and so on. Again, that symbol is called a radical, and the value inside the radical symbol is called the radicand. Again, this is all Algebra 1 review and geometry review. But there's a couple rules I want to review that we're going to be using in the next couple of days. First, when we add radicals, so if I want to add radical 2 plus radical 6, you can't add radicals unless they have the exact same radicand, and they don't. Now, sometimes we can simplify them to make the radicands the same, but in this case, we can't. So this is in its simplified form. But then if I gave you something like 2 radical 3 plus 5 radical 3, the radicands, okay, are the same, so I can add them. Now, we add them just like we do like terms. If this were 2x and 5x, that would be 7x. So in this case, it would be 2 plus 5, which would give me 7 rad 3 or 7 root 3. All right, and that's the addition, and the same properties apply for addition and subtraction. Now, the product properties are different because remember, when we get to multiplication, it's slightly different. If I give you the square root of 2 times the square root of 6, well, then I can multiply them. So it would be the square root of 2 times 6, which is the square root of 12. And then I would simplify the square root of 12 if possible, which we're going to do in a second. So the product property allows me to multiply. And vice versa, if I gave you the square root of 12, I could break it down into, say, the square root of 4 times the square root of 3, which the square root of 4 we know is the whole number 2, and that would give me 2 radical 3. So we're going to be using this product property a lot. All right, and the quotient property basically means that if I gave you the square root of 1 all over the square root of 4, I also could do this as the square root of 1 over 4. Which would give me 1/2. Either way, I'm allowed to do that. Now, you also learn something really important. And where did my page go? You learn something called rationalizing the denominator. So until you get to really higher math, we've all agreed in mathematical worlds that we won't leave radicals in the denominator. So this is a radical, and it is in the denominator of a fraction. So what you have to learn to do is something called rationalize the denominator. All you do is you take the denominator, whatever it is, and you multiply it to the whole fraction over itself. So I would take the denominator and multiply that entire fraction by the denominator over itself. Then I multiply across, so 1 times root 2 is root 2. Now what happens here is when I multiply root 2 times root 2 and they have the exact same radicand, that gives me root 4, doesn't it? Which is the number 2. And so I've just rationalized the denominator. Let me try another one. 2 all over rad 5. All right, so I'm going to multiply by rad 5 over rad 5, and I'm going to get 2 rad 5 all over 5. All right, so those are some of the basics. But then in geometry last year, I know that my students did this, and I know you did in the other class as well, you simplified square roots. We often did this when we were talking about the Pythagorean theorem, but a simplified square root is where there's no perfect squares or factors of perfect squares besides 1 under the radical. There's no fractions in the radicals, and there's no radicals in the denominator. So that's a simplified square root. All right, so let's look at an example. Square root of 12, okay? We want to find all the factors, all the perfect square factors in the number 12, but we really want to find the largest one. So in this case, the square root of 4 goes into 12, so we can rewrite it as the square root of 4 times the square root of 3, which would give me 2 rad 3. So that was that example I did for you a few minutes ago. Well, let's try another one. The square root of 27. All right, so remember, our perfect squares are square root of 1, square root of 4, square root of 9, square root of 16, square root of 25, square root of 36, square root of 49, square root of 64, square root of 81, square root of 100, square root of 121, and square root of 144. That's up through 12. All right, so I'm trying to find which one of these numbers could be a factor of 27. Well, hopefully you remember your factors of 9, and we know that we could rewrite 27 as the square root of 9 times the square root of 3, which would give me 3 rad 3. All right, let's try another one. The square root of 24. All right, so thinking about that square root list, I know that the square root of 24 can be rewritten as the square root of 4 times the square root of 6, 4 being the perfect square, so I can simplify that to 2 radical 6. All right, let's try another one. The square root of 18. The square root of 18, love it because it's another one of those 9 factors. That can be rewritten using the product property as the square root of 9 times the square root of 2, so 3 radical 2. All right, now we're going to be using this tomorrow in class, so it's really important that you understand these properties of radicals. So if you need to go back and rewatch, go for it. Talk to you soon.